This video is going to go through the process of using synthetic division to divide polynomials. It's different than long division, and it is used when your divisor is a linear binomial, meaning the exponent on your divisor is 1. Okay, so this is only used when the divisor is linear, right? Exponent equals 1. Okay, so the exponent on x is only 1. Okay, so synthetic division, the setup for it is much different than long division. And the reason for that is it actually gets rid of all the variables. So we don't have to multiply and subtract with the variables. We're looking at our coefficients. The first thing we want to find is, and set up, is find out where or what value makes your denominator 0. I'm going to change this. Okay, so x minus 5 equals 0, and we can see that x, that will be 5. That 5 is a significant number. When we set this up, we are going to set this up so that that 5 is separate and in its own box, all by itself. So that value is from the denominator. The other values that are important to look at are the coefficients of our numerator, which are 1, -3, -5, and -25. Those coefficients now go next to the 5 as 1, -3, -5, and -25. To complete setting this up, we're going to skip a line, draw a line, and bring down our first coefficient. So again, to review, these numbers, they are coefficients of your numerator. And this 5 comes from the denominator. Okay, that's where those numbers come from. And then we just bring down the first number. Now we're ready to actually apply synthetic division, which means we're going to take this 5 and we are going to multiply by the 1. So 5 times 1, and that number is then going to go right here. 5 times 1 is 5. That product goes right underneath that -3, and then we are going to add down. So -3 and 5 become a 2. So we add down. Once we have done that step, we do it again. We take the positive 5, and now we multiply it by the 2. 5 times 2 is 10, and that value gets written underneath our -5. We add down. -5 plus 10 is a positive 5. And we start the process one last time to do 5 times 5, which is a positive 25. And we add down, and we know that -25 plus a positive 25 is actually going to be a 0. Notice I've boxed this off. This number here is your remainder. Okay, so that remainder of 0 is going to be significant when we now write our final answer. These values of 1, 2, and 5, right here, the 1, the 2, and the 5, represent the coefficients for our quotient. We started off with our original at x cubed. So when we divide by a linear value, we're actually going to divide and bring down that power or degree down to 2. When we write our next term, it is then going in descending order, then x to the first, and then having our constant because that's x to the 0. So our final answer would look something like this: 1x squared plus 2x plus 5 with a remainder of 0, so we are all complete. To set up for a second example, then we're going through the steps. Our divisor is x plus 2. So where is x plus 2 equal to 0? And that is at -2. So that -2 is now the number in our box. Our coefficients, in this case, -2, a 5, a -1, and a +2. Those values are now going across -2, 5, -1, and 2. It is very, very important that we make sure these degrees of our x's are going in descending order. If they're not going in descending order, this division will not work properly. Okay, bringing down our first term of -2. We now multiply -2 times -2, and that value of 4 goes below the 5. And now we add, and this becomes a 9. And we multiply again. -2 times 9 is a -18. -18 minus 1 is a -19. Multiply one last time. -2 times -19 is 38, which means our last number of 38 plus 2 is going to equal a 40. Boxing that off, again, this is our remainder. Okay, this time it is not 0. We actually have a number for a remainder, so we're going to be using that in our final answer. The -2, the 9, and the 19, these three values that we have, right? -2, the 9, and the -19. These are now the coefficients of our quotient. Our quotient is always 1 degree less than what we started with. So we started with x cubed, so that means our answer for -2x is going to be x squared. Our next term of 9 is the coefficient for x. Our -19 does not have an x value. And now we have a remainder of 40, and just like with long division, we leave that over our divisor, which is x plus 2. This is now our final answer, our quotient for this polynomial divided by x plus 2. One final example that I want to go over with you. And if you notice, we have just 3 terms on the top. However, it is a degree of 4. Since it's a degree of 4, we actually are missing an x cubed, and we are also missing an x. Those missing terms, we must have placeholders. Okay, if you don't have a placeholder for these, your synthetic division will be incorrect. Okay, so first, that number in that box is going to be a -3 this time, right? Because x plus 3 is equal to 0. So that value is going to give us a -3. Our coefficients, we have 1, but 0x cubed, a -1, a 0x, and then, of course, 5. So we do have 5 terms, coefficients for this. 1, 0, -1, 0, and 5. You do have to have those zeros in there or your division will not be correct. Drawing our line, bringing down our first term. Negative 3 times 1. We multiply those again one last time to go through all these steps. This is going to become a negative 3. Add down. We're going to get negative 3. Multiply negative 3 times negative 3. This becomes a 9. Add down. Our next number is an 8. Negative 3 times 8 is a negative 24. Add down and multiply one last time. Negative 3 times negative 24 is a positive 72, giving us 72 and 5, which is 77. Boxing off that last term, this is our remainder. Okay, our final answer with these coefficients, our final answer degree, since we started off, our degree is 1 less than the original. We started off with x to the 4th, so our solution is now 1x to the 3rd minus, and we're just going to go down in descending order, 3x squared plus 8x. Our last term will not have an x, and then we're going to add our remainder over our divisor of x plus 3. This is now solved with synthetic division.